Now that we have finished the drill, what we're going to do is I'm just going to turn this drill page over, and I'm going to use this blank page to do our 4 theorems. And our 4 theorems, the first one is called the opposites theorem. Now, just in case you're wondering about these theorems, as far as memorization goes, you have to know how to use them. You should not have to look back and read the theorems. You should know how to use them. You don't have to know all the wording, but you have to understand them enough to use them. And in the opposites theorem, what we're going to be doing is we're going to be comparing theta and negative or opposite of theta, which you're going to see in just a second. So I'm going to leave a little space because I want to put some more notes up here. But what we're going to look at is for all theta, we're going to talk about what happens when we look at the cosine of the opposite of theta, the sine of the opposite of theta, and the tangent of the opposite of theta. All right, in order to do this, I'm going to sketch a unit circle, and this all has to do with signs, as in S-I-G-N-S, kind of signs. And this quadrant here, the first quadrant, the x is positive and the y is positive, and that's cosine and sine. When you divide them, you get tangent, so the tangent is also positive. I'm going to put the tangent on the outside. So cosine, sine, tangent. This quadrant is x is negative, y is positive, so cosine and sine. When you divide those, you get a negative. That represents my tangent. This quadrant, the x is positive. I'm sorry, it's not positive, it's negative, sorry. The x is negative. The y is negative. When you divide, you get positive. Here, the x is positive. The y is negative. When you divide, you get a negative. So realize that these stand for cosine, sine, tangent. Cosine, sine, tangent. Cosine, sine, tangent, because it's x and y. Cosine, sine, tangent. So, for all theta, so if theta, we usually assume that theta is in the first quadrant, if we're trying to think through an example. For all theta, so if theta is up here, if this was 30 degrees, negative 30 degrees would be down here in this quadrant. If theta was 120 degrees over here, negative 120 would be the same distance the other direction. So I want you to notice theta, opposite of theta. Theta, opposite of theta. What ends up happening in the opposites theorem, we are looking at quadrants above and below one another. Because theta would be here, the same distance in the other direction would be down here, above and below one another. If we traveled over here to the second quadrant, if we traveled the same distance the other direction, we'd end up here, above and below one another. So when we are looking at opposite of theta, we're looking at quadrants above and below. That said, the cosine up here in the first quadrant is positive. The cosine down here in this quadrant, well, look at that, it's still positive. It didn't change at all. So the cosine of theta and opposite of theta are both positive. Let's look at sine now. Sine is the y coordinate. Above and below, sine is positive and negative. Over here, sine is positive and negative. So it's the opposite of whatever the sine of theta would have been. So cosine stays the same, sine changes. Tangent. Look at the tangent. Above and below, tangent is positive and negative, negative and positive, tangent changed. So the opposites theorem, we look at above and below, and we look at the opposite angle. We look above and below, cosine stays the same, sine changes, tangent changes. Our second theorem is called the supplements theorem. I'll do this in a different color to help us tell these apart. And for the supplements theorem, as you know, supplements are angles that add up to 180. Or pi. And so we are looking at quadrants. Let's see what quadrants we would be looking at for this. Okay, well, first of all, let's go ahead and do our signs again. Positive, positive, which makes positive, negative, positive, negative, 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 positive, positive, negative, negative. All right, so if I was at 20 degrees up from the x-axis here, 20 degrees up from here is 160. 20 and 160 add to 180. So we are looking at quadrants side by side. So when I'm looking at quadrants side by side for all theta, the sine of pi minus theta, 180 minus the one angle gives me the supplement. So let's look at sine in side by side quadrants. Sine is the y coordinate, and side by side quadrants it stays the same. I also want you to note that this could have been written as sine of 180 minus theta equals the sine of theta. These mean the same thing. You can either write it as pi minus theta or 180 minus theta. Then let's look at cosine of pi minus theta. So again, side by side quadrants are supplementary angles. Cosine is the x coordinate, positive here, negative here. They are different, so it becomes the opposite sign. I want you to realize that this could have also been written like this. Just want to make sure, in case sometimes our worksheets will say pi minus theta, sometimes they'll say 180 minus theta. And then for tangent of pi minus theta, again, supplementary angles are side by side. Tangent is the opposite sign. Okay, and again, I could have written 180 degrees minus theta as opposed to pi minus theta. So these are the same, these are the same, and these are the same. That's my supplements theorem, angles that add up to 180 or pi. Now you might say down here, well, these angles are too large to add to 180. Well, these two angles here, though, can make up a whole pi, even though the pi is in the bottom quadrants. Okay, now let's go to our third theorem, which is called the Halfturn Theorem. And my half-turn theorem is when I move halfway around the circle, around the unit circle, So you add 180 degrees or pi. Okay? So let's look at that. Once again, let's do all of our signs. This is my positive quadrant. So my tangent is positive, negative, positive, tangent's negative, 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 positive. Be positive then negative, so that becomes negative. Okay. So your quadrants are, let's see, if you're in the first quadrant and you move halfway around the circle, you end up in the third quadrant. You move diagonal, so the quadrants are diagonal from one another. Okay. So we say for all theta, the tangent of pi plus theta, so tangent is right here on the outside. If I go diagonal, it stays positive. I could have written tangent of 180 plus theta. I could have written it as either pi plus theta or 180 plus theta. Now let's do sine. Sine of pi plus theta. Sine is the y-coordinate. Go diagonal. Goes from positive to negative. So it's the opposite of the sine of theta. Again, I could have written 180 plus theta. These are the same, just a different way of writing it, 180 or pi. And then I have the cosine of pi plus theta. Cosine is my x-coordinate, positive, then negative, because I'm moving diagonal. From opposite of cosine of theta. I could have also written cosine of 180 plus theta. Either way. Okay. All right, I have one more theorem to write, and it's called the complements theorem. And this is angles add up to 90 degrees. Therefore, they are in the same quadrant. For instance, 30 and 60 are both in quadrant 1, and they add up to 90 degrees. And what we're going to find out here is when that happens. I don't know if you guys remember, but on a previous page of notes, when we had our 30, 60 right triangle, 30, 60, this was 1, square root of 3, and 2. I want you to see that if I look at my 30-degree angle and I take the sine of 30 degrees, I get 1/2. If I then take the sine of 60 degrees, I get square root of 3 over 2. Now I'm going to take the cosine of 30 degrees. Cosine is square root of 3 over 2, and cosine of 60 degrees is 1/2. Do you see how the sine of 30 is the same as the cosine of 60? The sine of 60 is the same as the cosine of 30. Therefore, our theorem says that the sine of pi over 2 minus theta